In Activity 12, Rockets, students learn how thrust is produced in rockets. They first distinguish between a rocket engine and a jet engine, and then build a model rocket complete with an internal fuel source. You will need the following materials from the kit: Activity Sheet 9, Activity Sheet 12, index cards, vials with caps, seltzer tablets, and transparent tape. You will also need to provide safety goggles, pictures of the space shuttle, a pitcher, and tap water. To prepare for the activity, make a copy of Activity Sheet 12 for each student. Students will also need their copies of Activity Sheet 9 for reference and a pair of safety goggles. Each team of 4 will need a vial with cap, an index card, 3½ seltzer tablets, a pair of scissors, some transparent tape, and a pitcher of water. Also, encourage students to bring in pictures of the space shuttle. To begin the activity, remind students that all the flying machines they have learned about so far operate within the Earth's atmosphere, the blanket of air that surrounds the Earth. Guide students to understand that all aircrafts require air in order to fly. Ask students, could you fly a kite, a hot air balloon, an airplane, or a helicopter in space? Students should realize that they cannot fly any of these machines to space, as there is virtually no air in space. Explain that a rocket is a flying machine that gets its power from a rocket engine, which is the simplest yet most powerful type of engine made. Distribute a copy of Activity Sheet 12 to each student and point out the diagrams of the 2 types of rocket engines, which are solid fuel and liquid fuel. Inform the class that once the fuel in the solid fuel engine is ignited, it will burn continuously. When the fuel is used up, the engine simply stops producing thrust. In the liquid fuel engine, the flow of fuel and oxygen can be regulated so that the amount of thrust can be controlled. Explain that the pointed part at the top of the engine is called the nose cone, and the flared part at the bottom is called the nozzle. This nozzle can swivel to alter the direction of thrust to help steer the rocket. Explain that other than the type of fuel used, the rocket engines work the same way as these engines. They both burn fuel, which produces exhaust, that blows with great force out the nozzle at the bottom of the rocket. This thrust shoots the rocket into the air. Then, have students compare the rocket engines on Activity Sheet 12 with the picture of the jet engine on Activity Sheet 9. Students should discover that rocket engines are very much like jet engines in that they both produce thrust by the expulsion of exhaust from the back of the engine. However, unlike rocket engines, jet engines take in air from outside the engine, while a rocket engine has its own internal supply of air. Next, divide the class into teams of 4 and distribute the materials. Instruct students to build a nose cone out of the index card, trim it, then tape it securely to the bottom of the vial. They should then remove the cap, make a sticky loop from a small piece of tape, and press the tape loop to the inside of the cap. Distribute a seltzer tablet to each team and tell students to carefully stick it to the tape. Then, fill a pitcher with tap water and bring the students and the materials outside. Instruct the teams to spread out and fill their vials about 1/3 full with water. Make sure students keep the cap away from the water and the rocket until it is launch time. Students should stand at least 3 meters from the rocket and put on their safety goggles. Have one student from each team hold the vial upright with the nose cone pointing down and snap the cap gently onto the vial. Then, they should quickly turn over the vial, place it on the ground with the nose cone pointing up, and back away from the rocket. This should launch the rockets. After all teams have launched their rockets, ask students, "What was the fuel for your rocket?" Guide students to realize that mixing water with the seltzer tablet caused a reaction which launched the rocket into the air. Instruct students to repeat the procedure, this time using more fuel. Give each team 1½ seltzer tablets and fill the vials halfway with water. When teams have finished their second launch, ask students, "What effect did adding more fuel have on your rocket's performance?" Students should report more fuel resulted in a higher flight, and that the more fuel that is consumed, the greater the thrust. Encourage students to repeat the procedure a 3rd time, but this time have them remove the nose cone from the vial, then place the tape and a fresh tablet in the cap and fill the vials 1/3 full. When students have finished with their 3rd launch, ask, "What effect did removing the nose cone have on your rocket's performance?" Students should have observed that the rockets did not fly as high or as straight without the nose cones. Help students understand the nose cone gives the rocket a more streamlined shape, which allows it to move through the air with less resistance. Then, have students gather their materials and return to the classroom. When back at the classroom, pass around the collected pictures of the space shuttle and ask students, what kind of flying machine is the space shuttle? Some students may identify it as a spaceship, others will say it looks like an airplane attached to large rockets. Explain that the space shuttle is both a rocket-propelled spacecraft and a glider, and has both solid fuel and liquid fuel rocket engines. The tall, narrow rockets on each side of the craft are called solid rocket boosters, which contain fuel in solid form. The large tank attached to the solid rocket boosters and the shuttle contains fuel that gets pumped to 3 engines in the tail section of the shuttle. Together, these 5 engines provide enough thrust to propel the shuttle into orbit and to enable the crew to maneuver the shuttle as needed in space. Inform students that when the shuttle is orbiting in space, its wings are of little use because there is no air in space. However, when the shuttle returns to Earth, it needs the wings to help it glide to a safe landing. In short, the rockets send it into space, and the airplane-shaped shuttle glides back to Earth. To conclude the activity, discard the nose cones and any undissolved seltzer tablets. Rinse the vials and caps with water, wipe them dry, and return them to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.